Hello there, Mr. Sutton here, bringing you the IM314 Part 1 homework solutions on systems word problems. For this problem, we have Stephanie with a total of 12 coins, nickels, and quarters that are collectively worth $2.40. We just want to know how many nickels and quarters she has. So we're going to set up two equations, one talking about the total number of coins, one talking about their total value. And first we have to define our variables. I'm going to let the number of nickels, which is one thing we're solving for, be represented by n. And the number of quarters is going to be q. So we can say that the number of nickels, n, plus the number of quarters, q, should equal 12. That's how many coins we have in total. And in terms of the value, we should say the value of all the nickels, which is going to be 5, the 5 cents times n. That's the value of one nickel times the number of nickels, plus the value of all the quarters. That's going to be 25Q. That should all add up to 240 cents. And notice that I did everything in terms of cents so that I can avoid decimals. All right, so at this point I have to solve the system using substitution or elimination. Either one works fine on this, but I chose to go with elimination. So in order to have things that I can add together and cancel something out, I'm going to multiply this first equation by -5. That'll let me cancel out the n's. So multiplying by -5, we've got -5n minus 5q equals -60. And then just adding those two equations together, n's cancel as I predicted. 25q minus 5q is 20q. And then 240 minus 60 is 180. Dividing both sides by 20, we have q equaling 9, so that's 9 quarters. And then plugging that back in over here, we have n plus 9 equals 12. Subtracting 9 gives us 3 for n, so that's 3 nickels. On this one, we have a child's bank containing 70 coins, nickels and dimes, of course, and total value is $5.55. We want to know how many of each kind of coin there is in this piggy bank here. All right, so let's define our variables first. We're trying to figure out the number of nickels and the number of dimes. So let's let n be the number of nickels, and then d will be the number of dimes. And then we can write two equations. We're going to need two equations, actually, because there's two different pieces of information here. One equation is dealing with the total number of coins. If there's 70 coins, we can talk about what happens when we add the individual amounts together. So we know that the number of nickels, n, plus the number of dimes, d, has to add up to that total number of 70, since there's no other coins in this bank. So that's one equation we can use. We also have an equation we can use the total value here to create. We know that the total value of nickels and the total value of dimes has to add up to $5.55. The total value of all the nickels is going to be 5 cents times the number of nickels, so 5 times n. And then the value of the dimes, that's going to be 10 cents times d, and we're going to add that to the 5n. And that should all add up to, we'll say, 555, because I did this in terms of cents rather than dollars. Now we're going to go ahead and solve this. Now you could use substitution on this one if you isolate n or d in this first equation, but I went ahead and used elimination. I don't know if it's faster, but I just felt more comfortable doing it. So I'm going to multiply this first equation by -5, because that's going to give me a -5n, and that'll cancel out this 5n. Now, of course, you could have multiplied by -10 to cancel out the d's, or again, you could have also used substitution, and you'll end up with the same answers. So multiplying this equation by -5, because we have to take one path there, we've got -5n minus 5d equals, and now this is going to be -350. So now I can add these equations together, since I'm going to be able to cancel out those 5n's. And then 10d plus -5d is 5d on the left side. 555 minus 350, that's going to be 205. And if we divide both sides of this by 5, well, let's see here. 200 divided by 5 would be 40, so this is going to be 41 dimes. Now we can plug d back into any equation we want, but probably this is the best equation here to get the value of n. So we have n plus 41 equals 70. Subtracting 41, just careful at the end here, this is going to end up being 29, so we have 29 nickels. For this one, we're talking about the number of students at Ocean High School. The number of girls is 60 greater than the number of boys, and there's 1,250 students altogether. We want to know how many of each gender there are. All right, so let's see here. Let's define our variables. We're trying to find the number of boys and the number of girls. So let's let B be the number of boys and G be the number of girls. And we'll set up two equations. They said the number of girls at Ocean High School is, so we can say G equals, they said 60 greater than the number of boys. Well, the number of boys is B, and 60 greater than that means plus 60. So there's one equation. If we find the value of B, we can actually go back and plug it in here to get the value of G. We need one more equation, though. So that's talking about how many students there are altogether. If there's 1,250 students altogether, well, we know that the number of boys, B, plus the number of girls, G, has to add up to that total they gave us of 1,250. So there's our other equation. Now, you've got options here, substitution or elimination, but probably substitution is the best way to go because you've already got G isolated. If you use elimination, you're going to have to move things around here. So just plugging in B plus 60 for G over in this second equation, we've got B plus 60 now equals 1,250. So that's 2B plus 60 equals 1,250. Subtracting 60, that's going to be 1,190. And dividing by 2, well, let's see, 1,200 divided by 2 would be 600. This is 10 less, so that's going to be 595. There we go. So that's how many boys we have. And now we're going to plug that back into this equation over here to figure out the number of girls. So we've got 595 plus 60 for the number of girls, and that's going to be, let's see here, 655 girls. On this problem, looks like they're going to nickel and dime us. We have Jonathan with a total of 29 coins in nickels and dimes, and they're valued at $2.30. We want to know how many nickels and dimes he has. So we're going to set up an equation that talks about the number of coins and then the value of all those coins. And let's start by defining our variables. We're solving for the number of nickels and the number of dimes. We'll let the number of nickels be represented by N, and then dimes will be represented by D, the number of dimes. So we can say that the number of nickels, N, plus the number of dimes, D, whatever those are, they need to add up to 29 because that's how many coins we have. So that's our first equation. And we also know that the value of all the nickels, which is going to be 5 times the number of nickels, so 5 times N, plus the value of all the dimes, 10 times D, that should all have a total value of $2.30, so 230 cents then. I'm going to express everything in terms of cents. Now I can just solve this system of equations. We could use substitution or elimination. Substitution's not too bad. You could just subtract one of these variables to isolate N or D. But I'm going to use elimination. I just like it better in these situations. So I'm going to multiply this equation by negative 5. That'll give me a negative 5n that can cancel out this other n when I add the equations together. So multiplying by negative 5, so negative 5n minus 5d. And let's see, 29 times 5, well, 5 times 30 is 150, so this is going to be 5 less than that, so negative 145. Adding those equations together now, the n's cancel. 10d minus 5d is 5d. 230 minus 145, or plus negative 145, that's going to be, let's see here, negative 85, or no, positive 85. Positive number was bigger. There we go. And then dividing both sides by 5, well, 5 goes into 80 16 times, so 85 gives us 17 for the number of dimes. And then plugging that back into the other equation here, we've got n plus 17 equals 29. So that means if we subtract 17, the number of nickels must have been 12.